Hello, this is Mrs. Scarpo, and in this video I'm going to review the topic of residuals. When we have residuals, we have a set of data, like we do with this table. We then have a scatter plot with its regression line, or line of fit. In this case, the equation of the regression line is f of x equals 3x plus 6. The residuals are actually, the residuals, here we go, are the distances between the actual point and the regression line, which is the predicted value. So the distance from the actual to the predicted is a residual. Now, if you have your actual point is above your line, the residual is going to have a positive value. If your actual point is below the line, you're going to have a negative value. Now remember, I said that the equation of this line is y equals 3x plus 6. So in order to find the values, we need to take what the actual is and subtract what the predicted is. So we have the actual right here is 10. The predicted is going to be, if we substitute 1 for x, we're going to have 3 times 1 plus 6 for a value of 9 on that. So we have a residual value of 1 on this one. This next one is going to have an actual value of 13, and the residual value will be found by taking 3 times 2, that's the x value for that point, and adding 6. So that's going to be 3 times 2 is 6, plus 6 is 12, and the residual value for that is also going to be 1. I need to go back and check my table to find my other actual values. 7, 22, 28, 19. So that's at 7, 22, 28, 19. So now I can continue with finding the predicted value by continuing to take 3 times the x value and adding 6. So 3 times 3 is 9 plus 6 gives us a predicted value of 15 for this third point. For the next point, we have 3 times 4 plus 6. 3 times 4 is 12 plus 6. We have a predicted value of 18. For this fifth point, we have 3 times 5 plus 6. 3 times 5 is 15 plus 6 is 21 for the prediction. And for our sixth point, we will have 3 times 6 plus 6, so 3 times 6 is 18, plus 6 is a prediction of 24. Now, what we often use when we are determining if the residual plot tells us that a line is a good model, we use what's called a residual plot. And all that is doing is marking how far away each point is from the regression line. So everything is going to be based off of the x-axis in a residual plot. So at 1, that difference between 10 and 9, 10 subtract 9 is 1. So at 1, my residual is 1. At 2, my residual is 13 minus 12, which is also 1. So at 2, we have our residual at 1. At 3, remember I've been taking the actual minus the prediction. So I'm going to take 7 and subtract 15. Now remember, I said this should have a negative residual. Well, 7 subtract 15 is negative 8. So when x is 3, my point is 8 units below that regression line. At 4, we're going to take 22 and subtract 18, which is 4. So at 4, we have our point 4 units above the residual line. 5 is 28, subtract 21, for a change of 7 units above. And then our last one is 19 subtract 24, and again this one should be negative since our actual was below, and we have negative 5. So when x was 6, our residual was at negative 5. Now you want to see that you have points on either side of the residual line. If you have all of your residuals above it, that means the regression line was drawn below all of the points. You don't want to have that. If you have all of them below, that means your line is above all of your scatter plot points, which you don't want to have either. You want to have your regression line pretty much dividing your points, your data points, evenly on either side of that regression line. If you've done it correctly, if I find the total of my residuals, this is what you're going to end up with. If I have the correct regression line, what I'm doing here is I am going to take 1 and add it to 1, subtract the 8, add the 4, add the 7, subtract the 5, and this total, 1 plus 1 is 2, subtract 8 is negative 6, plus 4 is negative 2, plus 7 is 5, plus 5 gives me 0. If the sum of my residuals is 0, then I do in fact have the best fit line. I do have the best linear regression line for my data. And again, you want to have the data on either side of this line. The closer your residuals are to that line, the stronger your correlation will be. The further apart your residuals are from that line, the weaker your correlation will be. Now I have some examples and some reasons why the residual plots are showing that a line is not necessarily the best model for data. In this first regression plot, you'll see that we seem to be staying pretty close within this section of the data, but then it starts getting wider. Because of those increasing residuals, it means that the linear regression is a better fit at the beginning than it is at the end. Our data is related more by having this within a certain range than it is at the end of the data. So maybe we have a different curve or something that would be a good model, but not necessarily the line that these points create. In the second one, you'll notice that we have this curved pattern. We come up and then we start coming down. A pattern like that, where it's not evenly spread out all the way across, indicates that maybe a curve would be a better fit. Possibly quadratic, possibly exponential. But a line is not necessarily the best model because of the shape of this. The next data set, we have every other point, one is above, one is below. But I'm also looking at this and I'm looking at how far my data is from that x-axis. And we've got some pretty good jumps between points. So that tells me too that this data is maybe not the strongest correlation, depending on what the scale of all of our numbers is. But also, because this is alternating like this and we aren't really close to more than just this very first point, we might be missing some other pattern that's happening in the data. And our fourth one, the residual plot here shows an outlier at 10, which is going to skew any sort of regression line. But generally speaking, other than that outlier, it is fairly consistent. It is a fairly widespread. It's not, these points aren't all really close to being at 0 value for residual, but at least they're balanced on each side. So while a line could be a good model, skewed a little by this outlier, again, we are having, let me write that word a little bit better here. We have a situation where it may be a weaker correlation. Now, correlation and residual are not the same. The residuals are pretty much telling you if a linear model will be a good fit. The correlation coefficient tells you how strong or weak the data is related. If they're closer together, we're going to have a stronger correlation. If they're further apart, we're going to have a weaker correlation. And this concludes our review of residuals.